Okay, so the most important part of this is labeling your sides that you have. Now you've got the option of H, A and O. So H being the hypotenuse, which is the longest side. The longest side is always directly across from the right angle. So that's the first side that you can almost label H. So we've got nothing written on the hypotenuse. Not really very interested in that one. Opposite the angle is the angle. The side that's opposite it is your opposite. And then the side that's beside it that isn't your hypotenuse is your adjacent. Okay, so your two shorter sides are always your opposite or your adjacent, depending on the positioning of the angle. So that means that the sides I'm interested in are O and A. So if we compare that to SOHCAHTOA, the only one of those that involves O and A is the TOA part. So it's the tan. So it's this guy here that we're looking at. So tan of your angle, so tan of 20 is equal to your opposite over your adjacent. It's always in the order that it's in, so it's opposite over adjacent. So 6 over x. Now because x is on the bottom, the x is going to multiply up and the tan 20 is going to divide down. In other words, the way that we have remembered it is that the x and the angle will switch. Okay, so that's any time the x is on the bottom. So x in that case is going to be equal to 6 over tan 20. So putting that into our calculator, we get this answer here, 16.4848. Okay, so x is equal to 16.48486452, and it wants it corrected 2 decimal places, so we're going to leave our answer as x is equal to 16.48 degrees. Okay, just left as 48 because 2 decimal places would round it here. That 4 would need to be a 5 or higher if it was going to change this 8 to a 9. So it's not going to, it's 4, so it stays as 0.48. Okay, so we're going to use our SOHCAHTOA ratios to figure this one out. Different right angle triangle is shown on the right. It has sides of A, B and C. One of the angles is Y. In this triangle, A plus B is bigger than C. So the sum of the two sides is larger than the largest side. That's actually a necessity for all triangles. Use this to prove that the cos of y plus the sine of y is equal to 1. So we're going to use SOHCAHTOA for this. So we're going to label all our sides. This is my angle. The side opposite my angle is my opposite. Opposite the right angle is my hypotenuse, which means this is my adjacent down here. Okay, so we know that the cos of y would be the adjacent over hypotenuse because of SOHCAHTOA. Okay, so cos would be A over H, which in this case is A over C. Okay, this should be in blue really, but you get the point. The sine of y would be opposite over hypotenuse, SOH, which in this case is B over C. Okay. Which means if I was to do the cos of y plus the sine of y, that's the same as saying A over C plus B over C, which simplifies. Remember, adding fractions, the denominator is the same, so add the numerators A plus B, so it just stays A plus B, and that's all over C. Okay, so this is what we get as our answer, and how do we know that that's bigger than 1? Well, A plus B over C is bigger than 1 since A plus B is bigger than C, as we were told up here. So we've got a larger number divided by a smaller number, so that's going to give me a number that's bigger than 1, and that's that one done. Okay, so we're going to write our negative conclusion. So I'm going to say, therefore, A plus B over C is bigger. 1. QED. Quadratic demonstratum. I'm just going to take an opportunity to reiterate why this is true, that this is going to be bigger than 1 if a plus b is bigger than c. The reason being is that anytime you've got a bigger number divided by a smaller number, you're going to get a number that's bigger than 1. If you think about the logic that if I was dividing c by itself, so a number that was exactly the same as it, I would get exactly 1. And if I had a smaller number on top divided by a larger number, I would end up with an ordinary fraction which is less than 1.